In this videotape, we'll be taking a look at techniques for making through cuts at the table saw. Through cuts are cuts that separate the board into two parts. That is, the blade goes through the board. In doing this, you'll take a look at table saws, seeing two different types of guards, and you'll learn about the three components that make up a guarding system. We'll also explore the differences between ripping and cross-cutting and take a look at some of the OSHA requirements related to those. We're going to begin this tape with ripping. The cut you just saw me complete is known as a rip cut. That's a cut with the grain in the board. In addition to cutting with the grain, I have separated it into narrower parts. The control surfaces are this, the fence, and the table. It's important that the piece of wood you have and that you're going to rip has a flat face and edge, so as it goes along those control surfaces it doesn't rock. This reduces the chance of kickback. In making this cut, I use the push stick to control the cut, and there are a number of configurations that can be used. We'll talk more about that later. But now what I'd like to do is talk about the guard that you saw that was actually a barrier between me and the cut. There are three components to a guard in ripping, and I'd like to share those with you now. This guard has actually three parts to it, and under OSHA 1910 213C, those three parts are the barrier, which is the hood that actually covers the blade and reduces any chance of contact with it. The second part is the splitter, which is this piece of steel that, as the blade separates the wood into two parts, actually holds it open. That's a very important part, and I'll show you why. These two cuts were made with the same saw blade. As you look at these two, you'll see that this saw cut is uniform, it stayed open, and the two pieces are almost in the same plane. As you look at this piece here, you'll notice that the saw kerf is much closer here than it is here. In addition, as the cut was made, some stresses were released and these two pieces are no longer in the same plane. The nature of ripping requires that you use a splitter, because if the board closes on the back teeth of the blade, it can generate a kickback. Now, what happens then is, as the blade goes through, this actually splits or separates, or as OSHA calls it, spreads the board apart so it can't bind on the back teeth. That's a very important consideration when using a guard for ripping. So part one is the barrier, part two is the spreader or splitter, and then part three is this device in here called the anti-kickback pawl or dog, and it's a spring-loaded device. Now, how does that work? Well, as we're making a cut, as I feed the piece through, if there is a tendency for it to be kicked back because of some binding action, these actually will dig into the wood as it comes back. Sometimes they don't grab until the end, but they'll grab like so and hold. Depending on the hardness of the wood, they may grab any number of places. You can see that that started to dig into the board as we come down. There it's grabbing, and it grabs like so. Now, to make these work effectively, they should be sharp and pointed. So part of the maintenance on the guard is to make sure that those anti-kickback pawls or dogs are sharp. Now, this technique for ripping requires all three components to be done safely: barrier, spreader or splitter, and anti-kickback pawls. We've seen a basic rip cut. What I'd like to do now is reset and show you some techniques for making narrower rips, which are usually more challenging. The table saw is set up now for a narrower rip. I've moved the fence closer to the blade, and the piece would actually go through like so. Now, to control this piece, I prepared a push stick that would enable me to feed it through like so. Now, under OSHA 1910 213 S9, they make provisions for push sticks. OSHA doesn't really tell you what they ought to look like. They depend on you, the operator, to design them for the job you're doing. This is an example of that. This would enable me to grip that piece and push it through, keeping my hands clear of the guard and not inhibiting the operation of the guard. So you can make something like this easily. How will it work? Well, as the piece is positioned here, once I get into the blade, I'll actually pick this up, use it like so. It'll hook on the end of the piece, and I can push it through. Okay, so that's much like the rip cut you saw me make earlier, except we moved the fence closer. Now, if we were to make a rip cut like this, when we tried to move the fence, we would actually move it into the guard, and there would be the temptation to remove the guard. But I'd like to show you a technique that will enable you to make this rip cut without removing the guard. I'll set that up now and be back in a minute. For a very narrow rip like this, many table saw operators would be tempted to remove the guard. But here's a technique that works much better. I've got a piece of plywood and a piece of solid oak here that have been attached to make an L-shaped bracket. I've clamped them to the fence, but you could also use screws to attach this to the fence. Once this is in position, the edge of this plywood becomes the fence and controls the cut. The piece actually goes through like so. Now, you're probably saying, how does one push this through? This push block does the work. What I've got here is another piece of plywood that is exactly the same width as the plywood exposed here. It rides on here like so, lifts the guard, and will actually guide the piece completely through. Now, I've got a piece of plastic here with brass screws, so in the event that that would hit the blade, it wouldn't cause any damage. You could also use wood there. How narrow of a rip can you get? Well, that depends. You want to be able to use your anti-kickback pawls, and so if I were to go much narrower than this, I wouldn't be able to get the benefit of those. So this is about as narrow a rip as you can use this jig with. Other techniques are available, and there are other tools that you can use other than a table saw to make this work. Well, this is the technique. The width of this piece is about 4.5 inches out here, and so this is an equal width. You can make a push block up like this out of a piece of plywood and attach it with screws. That's how this was prepared. Something very easy to make, something anybody in the shop can do. What I'd like to do now is demonstrate the technique of making the cut. The cut I just completed is known as a cross cut. We actually made the board shorter by cutting across the grain. Now, the fence isn't on the table saw, it's a ripping accessory. The accessory for cross cutting is the miter gauge, and there are 2 slots in the table for its use. You can use either one. Right-handers tend to favor the left slot, however. Now, in making this cut, the OSHA provisions for guarding are 1910-213D, and it's a little different than C. The only real requirement is that we have a hood over the blade. Now, why is that? That's because the nature of the grain is such that in cutting across it, it doesn't close up on the back teeth of the blade. The wood behaves differently when you cut across the grain. So this guard meets the standard. It actually exceeds it because we're still using the other accessories. However, in this piece of wood, we didn't actually touch them, did we? Now, this is one guard that meets it. This is called the splitter mounted guard. I'd like to now show you what's known as the overarm guard and show you some of the differences of that. And I'll bring in another table saw to show you that now. Until now, the guard you've seen is known as a splitter mounted guard. This guard here is a little different, and it's referred to as an overarm guard. The guard barrier portion is actually suspended from an overarm that extends over the top of the table. This may come off of the operator's left or the operator's right, depending on the design of the guarding system. Now, in working with this one, you can use the splitter as a backup or a secondary simply because the splitter does not support the barrier guard. In this case, I have no splitter in position, so it meets the 1910-213D cross-cutting because no splitter is required. Now, let me show you a couple of things about a cross-cut on this machine. This is the standard miter gauge, and you'll notice there are a couple holes drilled in it. On this miter gauge, I've attached an auxiliary face made out of scrap oak to it. And the reason I've done that is to actually extend the control of the piece and sweep the scrap past the blade. And I'll show you that in a minute. But the important thing here, or most important in my mind, is that many operators will say, well, I can't see the blade, so I don't know where I'm cutting. That's really not a concern here, because if I bring this back like so, and I bring my piece of wood up until that pencil line touches this side, I know that if this is the piece I'm keeping, the saw blade is going to go on that side of the line through that slot that's already been cut. So I can use this as a tool to keep from lifting the guard all the time to check things out. What I would like to do then is demonstrate that technique. So let me move this out of the way. I split my pencil line, so I'm satisfied that that's a good cut. I could always sneak up on it a little more by moving it laterally if I needed to. So there's really no reason to see the blade. Another important thing that happened here is you'll notice that this auxiliary face pushed this cut off well past the blade. The guard actually dropped down and made it impossible for it to get back in. That's very important because sometimes as pieces sit idling under here, they can actually get trapped in the blade. Let me show you a piece where that happened. Unplug the saw. This piece of plywood was cut on a different machine, and as the cut was completed, the piece sat there fluttering like so. Well, it twisted slightly, and the weight of the guard caused it to lift up and be thrown back toward the operator. Now, if the operator is standing in the clear away from that, nothing would happen. And the thrust was not as great as if it had been trapped between the blade and the fence, because this isn't as stationary as the fence. Now, take a look at this semicircular arc here. That's fairly common when a piece is thrown as it backs into the blade. So this is an important thing to be alert to, and one of the benefits of putting the auxiliary face on the miter gauge when making a crosscut. Now I'd like to remove the miter gauge and show you the splitter so you can see how this can be used in a rip mode. First, we'll lift the guard. I've got the saw unplugged, so I'm comfortable working with it. I'll raise the throat plate out of here, and we have what's known as a pop-up splitter. Now, the pop-up splitter lifts up like so, and suspended from it are the anti-kickback dogs. When I put the throat plate back in, you can see that the splitter is perfectly aligned. This one pops up and down. There are others that are held in place with metal fasteners. In either case, this meets the OSHA requirements for ripping. And the anti-kickback pawls will grab the wood in most cases. Now, there's a good grip. Again, always check these to make sure they're sharp. These are pretty sharp, but they might even be pointed a little more. So, just depends. The harder the wood, the less likely they are. You shouldn't depend on those entirely. They reduce the likelihood of kickback, but that's no guarantee. So, when ripping, remember, you use the fence to rip, the miter gauge to crosscut. You don't want to use the fence in any cross-cutting operation. I've shown you some ways that the blade could pinch a piece between the fence and blade and throw it back at you. So we want to reduce any likelihood of kickback by controlling it every way possible. Well, I've shown you one application of the miter gauge. There is another to actually cut miters, which are neither rips or crosscuts, but an incline cut. So what I'd like to do is get a miter gauge and show you that technique next. In mitering, you're actually cutting at an angle to the grain. We'll take a look at that in just a second, but first I want to show you the setup. Originally in cross-cutting, I used this auxiliary face, and it's a high one. It goes straight into the guard and lifts it easily. When you go in at an angle, by scooping it out, it makes it easier for it to lift the guard. Now, I've got a line on here that marks my point. I've got a line here, and the long point of the miter lines up with the saw kerf, and again, I don't need to look under the guard to see that. There is one other consideration here. Sometimes if you have long or wide miters with some overarm guards, the piece would actually extend out here so that as it was cut, you may be limited by this overarm. No guard is perfect for all applications. You have to use some good judgment and decide which saw, which guard is appropriate for the operation you're doing. Or you may have to choose an alternate method of making the cut. But always be safe. Let's show you the technique here. I'll line that up again. There's my pencil line, the long point of the miter, positioned correctly. Now once again, I swept the scrap past the blade. There's no way that it'll get in contact with it. If it moves at all, it's going to come out like so. But there is always that element, if it's trapped under there, that point can get into the blade. So it's important that you sweep that past. One of the benefits of having an auxiliary face on the miter gauge. I've got the long point cut perfectly. I'm pretty satisfied with what goes on here. Now this operation didn't require a splitter, and nor does cutting sheet stock like plywood. But there are times that using the splitter can be beneficial in cutting plywood, and I'm going to be back to show you one of those situations. I have the power disconnected, and I've got the guard up just to show you what happened here. This is a square piece of plywood, and one of the places that people often get into trouble. As they make a cut like this, when they get to about here, if they shift their pressure, the piece can wedge, and what happened to this piece is it actually started to turn like this and throw back toward the operator. A square piece can do this, and you can see the bottom shows how the blade started to climb the piece in a semicircular action. Well, what probably happened here, the guard was down, but the splitter was not up. I'm going to lift the splitter and show you what would happen. In the same cut, if we were making this and we had the splitter up, as we got in like that, even if we shifted pressure and it started to climb, that splitter would resist that twisting action. So in many applications, the splitter has an extreme benefit even when it's not required under the OSHA legislation. So use it judiciously. Think of the applications. Well, that's the basics of through cutting. There are a number of things about guards to understand. If you haven't really got it all, I'd urge you to review the tape. It'll help you. Also, there are a number of great books on the subject, and I'd urge you to take a look at those. Thanks.